Welcome to all. I am Parthiban. In this presentation, going to discuss about the cogeneration and the waste heat recovery system, where the heat loss quality and quantity, as well as the heat waste system, will be discussed in the upcoming slides. First one is heat loss quality. Higher the temperature, higher the quality, and more cost effective is the heat recovery. It is necessary that there is some use for the recovered heat. Examples: preheating of combustion air, space heating, boiler feed water, process water preheating, etc. The high temperature heat recovery, according to the type of devices, the temperature range will be differ. There are some examples shown in the table. The nickel refining furnace and able to heat recover 1370 to 1650 degrees Celsius temperature. Aluminum refining furnace and able to recover 650 to 760 temperature degree Celsius. Zinc refining furnace 760 to 1100, copper refining furnace 760 to 815 degrees Celsius, steel heating furnace 925 to 1050, copper recuperatory furnace 900 to 1100. Glass melting furnace is also recover the heat up to 1000 to 1550, and fume incinerator also recover the heat 650 to 1450 at high temperature. And also medium temperature heat recovery types of devices, the temperature range will be differ. The steam boiler exhausts 230 to 480 degrees Celsius heat recover. The reciprocating engine exhausts 315 to 600 heat will be recovered. Heat treating furnace 425 to 650 degrees Celsius heat recover. Catalytic crackers also 425 to 650 degrees Celsius of heat recover. Handling furnace also, furnace cooling system is also similar to the catalytic crackers heat recovery temperature. The low temperature heat recovery will be depending on the sources. Process steam condensate temperature 55 to 88 degrees Celsius. Cooling water from furnace door 32 to 55. Bearing 32 to 88. Welding machine 32 to 88. Injection molding machine is also similar temperature of the welding machine. Annealing furnace 66 to 230 degrees Celsius. Air compressor 27 to 88. Also the forming dies is similar to the bulb temperature 27 to 88 heat recovery range. Internal combustion engine 66 to 120 degrees Celsius, and hot processed liquid 32 to 232 degrees Celsius heat recovered. The similar heat processed solid will be 93 to 232. The heat losses according to the quantity. It is equally essential to know the amount of heat recoverable and also how it can be used. The heat quantity shall be substantial to make it economically attractive to recover. Example: in a heat treatment furnace, the exhaust gases leave the furnace at 900 degrees Celsius at the rate of 2100 meter cube per hour. Heat recovery Q is equal to V into density multiply with heat capacity at constant pressure multiply with change in temperature delta T. The 2100, let's say according the previous data, the 2100 is represented that V, and then the density 1.19, and then heat capacity 0.24, and change in temperature 900 minus 180. Finally we can get 4,31,827 kilocalorie per hour. By installing a recuperator, this heat can be recovered to preheat the combustion air. Benefits of WHR. The direct benefit is that reduction in the utility consumption and the costs and the process cost. Indirect benefits will be the reduction in pollution, equipment size, and auxiliary energy consumption. Sources of waste heat: flue gas, vapor streams, convective and radiate heat caused from exterior of equipment, heat stored in products leaving the process, heat in gaseous and liquid effluent leaving the process. And development of WHRS, identifying sources and uses of waste heat, selection of suitable HRS, economic evaluation of selected HRS, selection of strategy to recover heat depends on the temperature of the waste heat gases and the economics involved. The waste heat recovery devices, going to discuss that upcoming slides. Here the recuperator is one of the heat exchange takes place between the flue gases and the air through metallic or ceramic walls. There are different types of recuperators are there. First one is the metallic radiant, B convective, C radiation or convective hybrid, D ceramic. This is the schematic diagram where we can see the outside ducting, tube plates. The tube plates is nothing but the supporting of tube through the hole in the plate. The preheated air can able to flow through the tube, exhaust the gas from the process. Center tube plates also provided to further support of the gas tubes. The inlet air from the atmosphere also enter and contact with the plates. Within this I will conclude this presentation. This continuation will be